Core 2 Progress Test Question 3. Figure 1 shows the curve y equals fx, where the function of x is 4 plus 5x plus kx squared minus 2x cubed. K is constant and the curve crosses the x-axis at points A, B and C. Given A has coordinate of minus 4, 0, show that k equals minus 7. They want me to show it, so I do not use k equals minus 7. I just use that to check that I've got the right answer. How can I show that? Well, we're told then that x is minus 4. If x is minus 4 and we substitute it into the function of x, y equals 4 plus 5 lots of minus 4 plus k lots of minus 4 minus 2 lots of minus 4 cubed. But we also know that when it's minus x is minus 4, y is 0. So 0 must also equal that. So let's simplify. We now have 4 minus 20 minus 4k. Oh, sorry, I've missed off the squared. It's plus 16k. Whoops. And then I've got minus 2 times 4 cubed, which is 64. That's plus 128. So if we do that, 4 minus 20 plus 128 gives me 112 plus 16k. And if I am then to finish this off, I know that minus 112 is 16k, and k is minus 112 divided by 16. Conveniently, it is minus 7, and we have now shown minus 7 is k. That's exactly what it says there. Now we're going to look at part B. Find the coordinates of B and C. Well, looking at the graph, B and C are where the graph crosses the x-axis. That means f of x, or our y value, is 0. We've been given a hint. We've been told here that x is minus 4 equals 0. So if we're told x, when x is minus 4, y is 0, we also know, as a hint, that x plus 4 is therefore a factor. What can I do with that information? Well, if that's a factor of this polynomial, if I divide that by x plus 4, I should get a quadratic, and I should get two potential solutions for B and C. Let's see. I'm going to rewrite this polynomial, so I've got minus 2x cubed minus k is 7, so it's minus 7x squared plus 5x plus 4. And if I use my box, I've got x here, I've got plus 4 here. If I want to get minus 2x cubed, first thing I've got to do is multiply this by minus 2x squared. So if I now want to do 4 lots of minus 2x squared. I now have minus 8x squared. I want minus 7x squared. That means I'd have to add an x squared. X times what will give me that x squared? Well, this must therefore be plus x, because x times x is x squared. X times 4 is plus 4x. Right. Let's keep going. I want the 5x. What do I do to 4x to get to 5x? Well, I need another x. X times what gives me that? Well, x times 1 gives me that, and 4 times 1 is 4. Oh, brilliant. That 4 ties in with this 4, so we now have factorised it. And our new quadratic is minus 2x squared plus x plus 1. And we know that must equal 0 because it's crossing the x-axis. Or it's on the x-axis, sorry. It's where it crosses the x-axis. So if that's the case, I can factorise this. I like to rearrange it first. So I've got 2x squared minus x minus 1 equals 0. The factors are 2 and 1. So I have got the factors of minus 2 are minus 2 and 1, and they add up to make minus x. So I've now got 2x squared minus 2x plus x minus 1 equals 0. And if I factorise this further, I've got 2x times x minus 1 plus x minus 1 equals 0. And my two options therefore are x minus 1 and 2x plus 1 equals 0. This means my x value must either be 1 or minus a half. But look back, it says find the coordinates. So far I've only found the x value. To find the y value, I need to substitute that into this polynomial. So if I put 1 in, I've got 4 plus 5 is 9, minus 7 is 2, minus 2 is 0. So y, of course, is 0. Let's just double check as well. Y equals, when it's minus a half, I'm expecting it to equal 0 too. I'll leave you to do that as well. And so my coordinates should be 1, 0, and minus a half